Sama Prof.
Mungkin di kesempatan berikutnya masih kami harapkan kesediaan Dokter Arifah ya, mungkin di
Ya,
semester depan atau tahun depan jika masih ada kesempatan, mungkin juga melanjutkan untuk mengisi sebagai dosen tamu. Kami harapkan ya, Prof ya, Dokter Arifah.
saya juga insya Allah.
Ya,
Apa
terima
sih?
kasih.
Ini sedikit-sedikit lima kok.
Belum absen.
Belum.
Mungkin
Jaya
kita bisa
jadi
mulai ya,
khusus.
Prof. Ya.
Halo.
Ayo, ya.
Halo,
Mungkin kami mulai
Oke,
Ibu
silahkan.
sekalian dan teman-teman mahasiswa.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Shalom budaya bagi kita semua. Selamat siang dan selamat datang dalam acara kuliah tamu yang diselenggarakan oleh Departemen Farmakologi Fakultas Kedokteran Hewan Universitas Gadjah Mada. Sebelum memulai acara pada siang hari ini, izinkan kami menyambut untuk yang pertama yang terhormat Ketua Departemen Farmakologi Fakultas Kedokteran Hewan Universitas Gadjah Mada, Profesor Dr. Hewan Agustina Dwi Wijayanti MP, dan yang kami banggakan seluruh partisipan serta teman-teman mahasiswa yang berbahagia. Pertama-tama, perkenalkan saya Salma selaku Master of Ceremony yang akan memandu jalannya acara pada siang hari ini. Pertama-tama, marilah kita panjatkan puji syukur atas kehadiran Tuhan Yang Maha Esa, karena atas karunia dan rahmatnya, kita dapat mengikuti sesi kuliah tamu dengan topik nanotoksikologi yang menghadirkan tamu terhormat dari Fakulti Perubatan Veteriner University Putra Malaysia. Ya, sebelum memasuki agenda pertama, perkenankan saya untuk menyampaikan susunan acara pada kuliah tamu hari ini. Untuk agenda yang pertama adalah sesi pembukaan, kemudian dilanjutkan dengan agenda utama, yaitu sesi materi dan sesi tanya-jawab yang akan dipandu oleh moderator. Lalu yang terakhir adalah sesi penutupan. Hadirin yang kami hormati, untuk agenda yang pertama yaitu sesi pembukaan, alangkah baiknya kita buka dengan berdoa terlebih dahulu. Menurut agama dan kepercayaan masing-masing, berdoa dipersilakan. Tidak ada kata cukup untuk berdoa. Selanjutnya adalah menyanyikan lagu kebangsaan Indonesia Raya untuk panitia yang bertugas, yang persilakan. Acara selanjutnya adalah sambutan yang akan disampaikan oleh Ketua Departemen Farmakologi Fakultas Kedokteran Hewan Universitas Gadjah Mada, Profesor Dr. Dr. Hewan Agustina Dwi Wijayanti MD. Kepada Profesor Dr. Dr. Hewan Agustina Dwi Wijayanti MD, kami persilakan.
Ya, terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, peserta dan juga mahasiswa kuliah tamu yang nanti akan diisi dari eh, dosen tamu kita dari University Putra Malaysia, Dr. Arifah. Pada kesempatan ini, pertama-tama saya ucapkan terima kasih kepada yang pertama tentunya kepada Dr. Arifah binti Abdul Qadir dari UPM yang telah bersedia meluangkan waktu dan nanti akan memberikan materi terkait dengan nanotoksikologi pada mata kuliah Farmakoterapi 2 dan Toksikologi, Departemen Farmakologi, Fakultas Kedokteran Hewan Universitas Gadjah Mada. Selamat datang, Dr. Arifah. Sekali lagi kami ucapkan terima kasih atas kehadirannya mengisi dan memberi materi kepada mahasiswa kami. Untuk selanjutnya, informasi juga mungkin kepada Dr. Arifah bahwa ini adalah kali kedua atau guest lecture yang kedua setelah minggu yang lalu. Kami juga mendatangkan dosen tamu dari Tarlac University Filipina, yaitu Dr. Crestel, yang pada kesempatan tersebut juga memberikan materi terkait ethno-veterinary medicine. Kemudian kepada mahasiswa yang mengambil mata kuliah farmakoterapi 2 dan toksikologi, mohon nanti untuk berpartisipasi aktif ya dalam mendengarkan kuliah dari Dr. Arifah, dan silahkan nanti untuk berdiskusi dan juga memberikan pertanyaan-pertanyaan ya yang baik ya demi tambahan ilmu yang akan diberikan oleh beliau. Jadi untuk materi yang akan diberikan ini saya rasa cukup baik ya terkait dengan nanotoksikologi. Mungkin nanti teman-teman mahasiswa bisa menanyakan apa itu nanotoksikologi, apa itu nanopartikel, apakah lalu apa hubungannya dengan pengobatan pada hewan, obat-obat hewan dan seterusnya ya, saya rasa cukup menarik. Dan kemudian yang terakhir juga kami sekali lagi menginfokan bahwa kuliah tamu ini merupakan program yang kami rencanakan untuk terus berlangsung dan berlanjut, yaitu join apa namanya tim teaching ya, tim teaching, kolaborasi tim teaching antara dosen di Universitas Gadjah Mada dan dosen tamu yang dari luar Indonesia. Ya, kami sangat berterima kasih dan sangat bersyukur bahwa pada kali ini kami bisa kembali menyelenggarakan kuliah tamu bersama dengan Dr. Arifah binti Abdul Qadir dari UPM. Saya rasa begitu ya dari kami, saya cukupkan sekian dan semoga nanti dalam kuliah nanti cukup menarik ya, dan dengan ini saya nyatakan kuliah tamu dengan topik nanotoksikologi bisa dibuka dan dilaksanakan. Terima kasih atas perhatiannya. Selamat siang. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Profesor Dr. Hewan Agustina Dwi Wijayanti MP atas sambutan yang diberikan. Sebelum memasuki acara inti, kami mempersilakan untuk seluruh partisipan dapat menyalakan kamera untuk sesi dokumentasi terlebih dahulu. Diharapkan partisipan juga dapat mengganti background dengan virtual background yang telah disediakan. Kami beri waktu mungkin 3 menit sampai 13.17 ya teman-teman untuk bisa menyalakan kameranya. Fitriana S.Farm, apoteker MSc PhD yang tidak kalah luar biasa dengan pembicara kita pada hari ini. Berikut adalah CV dari Bu Ida, ya teman-teman, karena Ibu Ida ini adalah asisten profesor di Universitas Gadjah Mada yang menempuh pendidikan S1-nya di Universitas Islam Indonesia, kemudian jadi Magister Sains di Magister Sains Veteriner, kemudian untuk PhD programnya di School of Pharmacy Taipei Medical University. Untuk research interest dari Bu Ida sendiri itu adalah farmakologi veteriner dan juga oftalmologi veteriner. Tuh. Ya, tanpa berlama-lama lagi untuk memulai sesi inti pada siang hari ini, izinkan saya untuk menyerahkan acara kepada moderator kita, Ibu Ida, yang akan memandu jalannya diskusi. Wadah Ibu Ida, kami persilahkan.
Terima kasih Salma atas membantu membuka acara pada siang hari ini, Jeh. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera untuk kita semua. Yang saya hormati Ibu Profesor Dr. Arifah Abdul Qadir, kemudian para dosen dari Departemen Farmakologi, para mahasiswa yang saya sayangi dan seluruh peserta yang hadir pada kesempatan pada siang hari ini. Kami berbangga nggih, bisa membuka sesi kuliah tamu dengan judul nanotoksikologi yang akan disampaikan oleh narasumber kita yang sangat berkompeten di bidang ini. Izinkan saya untuk memperkenalkan narasumber kita pada siang hari ini. Saya boleh minta tolong untuk menampilkan CV Prof. Arifah? J. Terima kasih. Pembicara pada siang hari ini yaitu Profesor Dr. Arifah Abdul Qadir. Beliau merupakan dosen senior di Departemen Veterinary Preclinical Science di Faculty of Veterinary Medicine, University Putra Malaysia. Beliau merupakan lulusan dari alumni dari University Putra Malaysia, kemudian untuk Doktor of Philosophy Pharmacology dari The Royal Veterinary College University of London. Publikasi beliau sangat banyak sekali, lebih dari 100 publikasi dan buku sebanyak 2. Kemudian untuk H-index Scopusnya lebih dari 20. Kemudian spesialisasi beliau di veterinary pharmacology, kemudian subspesialisasinya di bidang toksikologi veteriner, phytomedicine, nanoscience, nanotechnology, and ruminant disease. Adapun riset interest beliau yaitu comparative efficacy of selective phytobiotic with haloquinone and tetracycline in broiler chicken, effect of great dose dietary supplementation of bitter betel leaf meal and Pizzeria odorata leaf meal on growth promoter and growth performance, apial ileal digestibility and gut morphology in boiler. Then pharmacokinetic of free oxytetracycline and oxytetracycline glucose cell calcium carbonate based nanoparticle in biopsy mice. in vitro toxicity, cytotoxicity evaluation of oxytetracycline load cockle cell derived calcium carbonate argonate nanoparticle, in vitro investigation of cytotoxicity and antioxidative activities of Ardisia chispra against the breast cancer cell line, and etc. Kemudian beliau juga telah banyak meluluskan banyak postgraduate student, baik PhD maupun master. Kemudian beliau juga sebagai Associate Professor University of Malaysia, sebagai Head Department of Technical Science, Faculty of Veterinary Medicine, University Putra Malaysia. Beliau juga sebagai Expert Reviewer Department of Veterinary Science, Ministry of Agriculture, External Expert Member, Technical Group 4, National Antimicrobial Resistance Committee, Ministry of Health, dan banyak sekali pengalaman beliau yang tidak mungkin saya bacakan satu persatu. Mohon maaf, Profesor. Kemudian beliau juga aktif di berbagai, selain penelitian juga pengembangan untuk nanoformulasi dan untuk aplikasi di klinis pada hewan. Nah, pada siang hari ini beliau akan membahas secara komprehensif tentang konsep dasar nanotoksikologi, kemudian sifat-sifat dan kimia fisika dan kimia nanopartikel, kemudian mekanisme toksiknya, strategi pencegahan efek toksisitas, serta penggunaan seperti penggunaan antioksidan, dan tentu saja bagaimana aplikasi nyata dari nanopartikel dalam kedokteran hewan termasuk pengobatan, pakan maupun vaksinasi. Tanpa berpanjang lebar, mari kita sambut pemateri kita pada siang hari ini kepada Profesor Dr. Arifah Abdul Qadir. Kami persilahkan. Time is yours, Profesor.
Si Dr. Ida Fitriana, Ibu
Baik.
Prof. Agustina yang memberi peluang ya untuk memberi syarahan di Fakulti Kedokteran Haiwan Universiti Gajah Mada. Ini adalah pengalaman pertama saya di UGM. Terima kasih Prof dan Doktor. Dan saya juga mengucapkan selamat berkenalan dengan para mahasiswa-mahasiswi Fakulti Kedokteran Haiwan UGM. Semoga syarahan saya memberi sedikit manfaat kepada semua yang akan melanjutkan pelajaran ke peringkat yang lebih tinggi, ke peringkat masters, peringkat PhD. Ini adalah permulaan ya. Program ini adalah program kedokteran haiwan adalah program permulaan dalam kerjaya masing-masing, dan semoga semua akan berjaya dengan cemerlang dan melanjutkan pelajaran ke peringkat yang lebih tinggi, insyaAllah. Jadi tanpa melengahkan masa lagi, saya akan memulakan syarahan saya. Syarahan saya dalam bahasa Inggeris, tapi saya boleh berbicara dalam bahasa Melayu juga. Kalau ada soalan dalam bahasa Melayu, boleh bertanya, tak ada masalah. Ya, saya bisa dengan bahasa Indonesia, sebab bahasa Indonesia dengan bahasa Melayu adalah bahasa serumpun. So kami faham sesama sama kita ya, bahasa adalah sama, tak ada perbezaan, cuma ada perbezaan sikit sahaja ya. Okey, saya mohon maaf sebab slide saya dalam bahasa Inggeris juga, tapi kalau ada yang kurang faham, tak berapa tahu mengenai terminologi yang saya gunakan dalam slide saya, mohon bertanya ya. Okey, sekarang saya akan share slide saya.
Permisi, Prof. Mungkin dari kami bisa membantu menayangkan slide-nya.
Oh, boleh je. Kalau,
Oh ya, baik.
thank you,
Oh ya,
MC, for the kind introduction and also helping me with the slides. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening. Today, I'll be taking you through the lecture on the nanotoxicology. It's going to be a very brief review, but just in case you feel that it's a bit heavy on your side, please inform me. Yeah, we can go accordingly. Right. Before we dive into the details of the presentation, I would like to take a moment to give you an overview of what I'll be covering in the next 2 hours. We will explore on the terminology such as nanotoxicology, nanoparticles, possible strategies to circumvent nanotoxicity. What are the applications of nanoparticles in veterinary medicine? Yeah, that's very relevant to your course. And lastly, I would like to conclude my presentation. And I hope I'll share some of these insights that will be valuable for you in future, inshallah. Okay, right. Okay. We'll talk about nanotoxicology. Right. To be honest, this topic usually I teach the postgraduate students, the masters and PhD students. For undergrad, well, they're not really exposed to nanotoxicology. It's only when you take a postgraduate course. But anyway, I think it's a very good topic. It's a good information for you to know more toxicology before you pursue your studies. So nanotoxicology is an aspect of nanoscience that deals with the study of adverse effects. So this will be the adverse effect of nanomaterials, nanomaterials or nanoparticles on living organisms. Right? So what do you mean by nanomaterials? What's the difference between nanomaterials and nanoparticles? So nanomaterials, are materials with at least one dimension in nanoscale, right? Okay, so nanoscale goes from 1 to 1,000 nanometers, so very small, which is equivalent to 0.1 micrometer. Okay, very small. While nanoparticles, are very specific type of nanomaterial with all the 3 external dimensions, are in nanoscale. Okay. Actually, nanoparticle is a subcategory of nanomaterials. Okay. So nanoparticles, they are widely used as nanomedicine, and nanocarriers of drugs due to their small size and exclusive properties. However, the size, the morphology, the surface functional groups, such as functional groups and those dependent properties may also responsible for their toxicity, towards normal cells, healthy cells, and the tissues and the organs surrounding, nanoparticle. Okay. Other definitions, of nanotoxicology is a study of the interactions, of nanostructures with the biological system, right? So biological system usually refers to a living organism, right? So nanostructure is referring to the nanoparticles, yeah, with the emphasis on elucidating the relationship between the physical and chemical properties. Okay, if you look at the figure, yeah, there, yeah, it's quite small, but yeah, I can use my cursor. But no, I haven't finished. Previous slide, please. Can you see my cursor on the slide? Yeah, you can. Okay, never mind. Previous slide. I'm still in previous slide. Yeah. So non-toxicology, yeah, is actually, yeah, we are trying to study the relationship between the physical and chemical properties. Yeah. So physical here referring to morphology, yeah, of the nanoparticle. Okay, whether it's a nanotube or nanofibers. Okay, and then surface characteristic. Okay, this is the coating of the nanoparticle. The particle size, yeah, how big is the nanoparticle? Okay, all this referring to the physical properties. Okay, and the others would be the free nanoparticles, whether it's in the free form or in the fixed form, and the metabolism. Yeah, these components are referring to the chemical properties. Yeah, because by chemical reactions, yeah, by enzymatic reactions, the nanoparticle, which is or drug-loaded nanoparticle, will need to be metabolized. Yeah, similar to drug metabolism, right? So so that, you know, the chemical property of the nanoparticle will also determine, yeah, the metabolism of that particular drug-loaded nanoparticle, right? Whether it's in the fixed nanoparticle or free nanoparticle, also of concern. Okay, usually free nanoparticles are less toxic, yeah, as compared to the fixed nanoparticles, because sometimes fixed nanoparticles, these nanoparticles, they tend to clump together, you know, they tend to clump together, and they call it agglomeration. Yeah? I will go through the term later on. Yeah, don't worry. Yeah, I'll discuss that further on. Yeah, so they tend to clump together and produce toxic effect. Right? So the next slide will show you on the nanomaterial growth trend from 2010 to 2015. So here the concern is there is an increase in the nano-based products, yeah, between 2011, yeah, if you look at 2011, yeah, to 2015, it is increasing. The pattern is increasing, yeah, and even now, I suppose that there is an increase of use of nano-based products, yeah, in medicine. Okay. Right. So this figure shows the composition of nanomaterials. Yeah. So this is adapted from Wentz et al. 2015. So that's the reference that I use. Okay. So the metal, as you can see there, yeah, the metal nanoparticle, the nanomaterials, yeah, composed of metal, yeah, carbon, silicon, and others. Yeah. So among the all, yeah, as you can see in the picture, the metal nanomaterial, yeah, it constitutes about 37%. So mainly are metal products, yeah, and followed by carbonates, okay, or carbon and silicon. Okay. So the others, very minimal, yeah, and some are not advertised, about 49% not advertised the real source of the nanoparticle. And out of the 37 metal nanomaterials, as you can see here, 65 is silver, silver nanoparticles, followed by titanium, and the others are just like 7.6%. So mainly they use silver and titanium. This is based on the research done. And as for the carbon nanoparticle, you can see here its carbon is 44%, followed by CNT. CNT referring to carbon nanotube. All right, carbon nanotube, and graphene about 11%. Fluorine and graphene about 11% respectively. Okay. Okay, now let's see on the nanoparticles. So what are nanoparticles? We talk about nanoparticles. When you talk about toxicology, nanoparticles is closely related. So it is derived from a Greek word, meaning that it's small or dwarf. Kalau orang bahasa Melayu, kita sebut kerdil. Betul? Betul tak? Dalam bahasa Indonesia kita sebut apa?
Kecil.
Kerdil.
Kerdil.
Sama je kan? Itulah bahasa kita sama. Lepas tu this are the microscopic, so boleh dilihat dalam mikroskop aja. Pakai mikroskop aja. Kalau mata kasar memang tak nampak. So microscope particle within the size range of 1 to 100 nanometers in diameter. And the word nano can be used as a prefix. That means can be used before a term, for any unit, a billionth of that unit. Okay, nano. So coarse particle, adalah lebih kurang 10 nano micrometers. Small particle, kita sebut small particle, dia kurang daripada 2.5 micrometer. Manakala nanoparticle adalah 0.1 nanometer. Kecil, kecil, amat-amat kecil, amat-amat halus. Memang susah tak nampak. Dan dia, kalau kita tukarkan kepada nanometers, dalam lingkungan 100 nanometer. Tapi nanometer ni 100 yang paling besar lah. Yang paling kecil 1 nanometer. Kita boleh bayangkan, memang tak nampak langsung. Macam sangat-sangat halus. Okay. So nanoparticles, generally they must have at least one external dimension, 1 to 100 nanometer, but usually they will have three dimensions of 1 to 100 nanometer. And then the physical chemical characteristic, made them very useful in applications, because in medicine, some of these nanoparticles are used as drug carriers. They call it drug nanocarriers. So, because sometimes when you use drug, drug can just cause high concentration of drugs. They can cause injury to the cell or the tissues, in high concentration. Whereas with nano, if it's attached, or loaded with nanoparticle, there'll be a slow release of the drug over a period of time. So that will lead less toxic effect of the drug. So, however, we must bear in mind that all these properties can be potentially toxic. So they have like they are very useful. At the same time, we must be aware of the toxic effect. Okay, this is just to show you, the stages in nano drug development. Okay, so firstly, we need to synthesize, and characterize the nanoparticle, right? That includes the defining the physical, chemical characteristic, and then what are the other nanodrug formulation, and then followed by the biocompatibility and nanotoxicology. So, the second step, in the nanodrug development is the nanotoxicology. This is to see, the interaction with biological processes and fluids, in the body, the interstitial fluid, the body. How does it interact? Does it produce toxic effect? Or is it safe to use? And as you know, toxicity testing is very, very important in medicine. There is also in vitro testing. So in vitro testing will be the first step of testing nanodrug, and then followed by in vivo. So usually, if there's positive result with in vitro, usually we do the cytotoxicity assay, such as MTT assay, trypan blue assay, and then if you see like positive results, then you can proceed to in vivo. So in vivo test, usually you need the clearance from the ethical committee, IACUC committee. Komiti tu ada juga di Fakulti Kedokteran Haiwan di Indonesia di UGM ada tak komiti etika haiwan?
Ada.
Sama
Ada, Prof. We have.
So it's very similar setup even in Malaysia. Any testing, in vivo testing, we need to get the approval from the ethical committee. And the next step would be the kinetics and the dynamic studies. And then they will do the modeling, PK/PD modeling, and finally they can scale up the reproducibility. So this is when they want to produce in large quantity. They need to see whether is it economically viable, sustainable. So these are the questions need to be posed before they develop the drug. Right. So just to highlight a little bit on the cytotoxicity assays, So these are the assays, the in vitro assays, It's one of the major assays applied in vitro toxicology assessments. So usually before you do your in vitro, in vivo testing, usually you need to present the in vivo testing results, to ACUC committee, and then they will allow you to proceed with the in vivo testing. And it has major advantages, as you can see, less time consuming, can be done very fast, cheap, because you do it in the lab, and it has no animals, easy to perform and reproducible, it can be produced many times. You can repeat the assay. You must get the mean value of 3 times, so you repeat the assay 3 times. And the next slide shows the research article. This is just to share with the students. I did do work on this cytotoxicity assay, in vitro, to evaluate the oxytetracycline. I'm sure you're familiar with oxytet. We use this for in large animal for CLA, caseous lymphadenitis, and many other problems, mainly in large ruminants and small ruminants as well. And what we did is we load this drug, with calcium carbonate, nanoparticles, and this calcium carbonate nanoparticles, they are derived from cockle shell. And my PhD student was Sherry Fett, and she did her PhD with me. But not only this was just one chapter of a PhD thesis. So she did the whole characterization, synthesis, PK study as well. Cockle shell derived calcium carbonate particles. So basically, what we did, is I think it's quite small, but you can refer to this paper later on. It's in Nanoscience, Nanotechnology Asia, published in 2019. So basically, what we did, we exposed, to concentrations from 6.25 to 100 microgram per ml of calcium carbonate nanoparticle, and the oxytet loaded nanoparticle. So we had like three different groups. First, the calcium carbonate, the nanoparticle only, and then followed by the oxytetracycline loaded calcium carbonate nanoparticle, and lastly, just the oxytetracycline. And we exposed to the normal mouse fibroblasts, cell line. I'm sure you have heard about this maybe in future. So this is the normal cell line that we use to test the cytotoxic effect. Okay, and in 6 well plates. So we exposed that for 24, 48, 72 hours, and the cell viability was determined using the MTT assay and also the trypan blue assays. So we did 2 assays to confirm, is it safe or is it cytotoxic to the normal cells. And alhamdulillah, the results were good. Both assays, they showed cell viability. So both assays showed that the calcium carbonate derived from cockle shell, and also the OTC loaded with the cockle shell derived calcium carbonate, they had high cell viability as compared to oxytetracycline alone. So having it loaded with this nanoparticle decrease the toxicity. So this is how one way we can reduce the side effect or the toxic effect of drugs. So okay, now we look at the properties, properties of particles. So the nanoparticles properties. Okay, so this they have okay. So basically, the middle figure, it shows the advantages of nanoparticles for drug delivery. So what are the factors that determines that the nanoparticle is suitable for drug delivery? And the advantages here are listed as it has got the large surface area, higher carrier capacity, ultra small size, because the nanoparticles are small, increase of bioavailability. So increase of bioavailability refers to I think this is the concept is very similar. Bioavailability, I'm sure you have learned in your pharmacology. So it always refers to the extent and the rate at which a drug or a metabolite enters the systemic circulation. So so if it says increased bioavailability, that means the extent and the rate it's better with having the nanoparticle as compared to the drug alone. Then the others would be a controlled release for uniform drug delivery. So this is what I mentioned, yeah. So having been loaded, yeah, with the nanoparticle, yeah, the drug loaded with nanoparticle, there'll be a controlled release or uniform drug delivery to the system. Okay. Surface functionalization, the coating, surface coating of the nanoparticle also plays an important role. And so all these properties, yeah, that being mentioned, yeah, they can determine the nanoparticle biological safety, efficacy, or toxicity. Okay, so far so good. Any questions? Senang nak faham tak? Boleh faham?
Not yet, Profesor. Paham,
Boleh.
insyaallah.
Kalau ada yang faham ni, saya boleh ulang. Saya cuba dalam bahasa kita lah. Ya, kalau yang tak faham. Okay. So this slide shows on the properties of nanoparticles. Because of the very small size, they are very unique. Yeah, they have very unique physical and chemical characteristic. Yeah, so which make them very suitable in the many applications. Yeah, in medicine, in veterinary medicine as well. Okay. But as I mentioned, since it's very useful, yeah, but at the same time, you know, they might affect, yeah, animals or humans, and also the environment adversely. They might have some side effects which we must try to circumvent. Yeah? Let's try to reduce the side effects, and we must find ways how to reduce the side effects if it's present. Next slide, yeah, shows the properties of nanoparticles, yeah, that influence toxicity. So there are a few I've listed here, yeah. And the first one, of course, you know, the size and surface area. It's very interesting to know that this nanoparticles, they have higher toxicity. They have higher toxicity. Right? Any questions? Yeah, you can just ask them. So in other words, yeah, these nanoparticles have higher toxicity in comparison to bigger particles with similar composition. Yes, similar material, but the one that in nano form, yeah, they have higher toxicity. Why? So the rationale would be because when the size decreases, yeah, the nanoparticle size decreases, yeah, the ratio of the surface area, yeah, of the nanoparticle, the surface area to volume, yeah, exponentially increases. And when the surface area increases, then it is exposed to many tissues and many organs, yeah, which will affect the biological or the chemical activities. Okay, so that is the reason. Smaller the size, yeah, is more toxic. Yeah, so that is very interesting. Yeah, this nanoparticle. And the next slide, yeah, shows a table. Yeah, the particle size, surface area, and the number. So we can see the correlation between the diameter of the particle to surface area and the number of particles. So look at the table. Yeah? You can see 5 to 5,000. So 5 nanometer, very small, kecil, ya, sangat-sangat kecil. Tapi surface area-nya, ya, adalah 12,000, ya, unit, ya, dinyatakan di situ. Dan juga number of particles tu, berapa tu? 1 juta lebih. 1 juta lebih. So maksud dia lagi kecil. Ni number of particles ya lagi banyak dan surface area besar. So itu adalah korelasi di antara size partikel tersebut, surface area dengan bilangan partikel. So kita boleh tengok nanopartikel yang ada high surface reactivity. That means yang ada surface area dia besar, besar kemungkinan akan menghasilkan ROS. So saya tak tahu, mungkin pernah dengar ROS. ROS refers to reactive oxygen species. These are radicals that will cause damage to DNA and leading to inflammation, will cause damage to DNA and apoptosis. Apoptosis will follow, and the others, the ROS also involved in some situation where they will cause inflammation, necrosis, and others. So having ROS, high level of ROS is not good. It leads to cytotoxicity, genotoxicity. So these are the two toxic effects that we will look into later on. Okay. Next slide. So next one is on the shape, the shape of the nanoparticle. So you can see the shapes here. They have nice shapes here: cubic, triangular, oval, rod, spherical, needle, star. Cantik, semua ni cantik belaka. Tapi dekat sini memang research telah dibuat, katakan bahawa shape adalah sangat penting, shape nanoparticle sangat penting, determining the biological activity and as well as the toxicity. So the silica nanoparticles have shown potential as a drug carrier in oral drug delivery. So mainly they are made of silica. Okay, the other one would be the needle-shaped nanoparticles. They cause more toxicity than those spherical shape because they are more efficient, because they're more efficient at adhesiveness to the surface of the target. Adhesiveness ni macam dia lebih macam senang nak melekat pada permukaan target sel. Sebab dia dalam bentuk needle panjang. Okay, seterusnya adalah aspect tiga, aspect ratio. Slide seterusnya. So
Next slide.
yes. So number tiga, the properties that influence toxicity is the aspect ratio, right? So this ratio refers to the width, the width of the nanoparticle. Yang saya ada dalam gambar raja sebelah tu, it's about 1. Okay. It's about 1, and the greater the NP aspect ratio, the higher the toxicity. Whereas the nanotube, as you compare here, has got a ratio very close to 0. Okay, so it's safer, as compared to this spherical nanoparticle, right? Okay, so with this smaller aspect ratio, or reduced aspect ratio, which is close to 0, the absorption, for example, in the intestine, is increased. The absorption is increased. while the excretion of the nanoparticles, through urine is reduced. So better absorption with the nanoparticles that have ratio are very close to 0. Okay, then the next aspect would be the crystallinity. So this actually affect the toxicity as well. Okay, so crystallinity is referred to the polymorphs. Polymorphs, the different crystalline structures. These are the chemical structures. They have different crystalline structures of the same chemical composition. Chemical composition is the same, but the structure of the crystalline is different. So they show a different chemical and physical properties. And, the next one, would be the surface area, the surface coating. Number 5. So the surface coatings of nanoparticles are applied in order to modify its property. Okay, so this is actually in a way it's an intervention to convert the harmful particles to be non-toxic. So the surface coating is very important, because they are applied to modify the property of the nanoparticle, right? So the surface of the particle, the core, is covered with a variety of layers. So the objective of the coating may be tailored to stability, wettability, and dissolution. Okay. So there's a question, I think, in the chat box. I will finish this slide and then we will see. Look at the question. So dissolution here refers to dissolution is the process where a solute, which can be a solid, a liquid, or a gas, it dissolves in the solvent to form solution. Okay, it'll be in the solution form. So this in this case, the nanoparticle is a solute, so which can be a solid thing, so it needs to dissolve in a solvent. Solvent here refers to the living organism, usually refers to the interstitial fluid, and then to form the solution, right? So with a coating, they can convert the harmful particles to non-toxic, while harmful particles can become more toxic, due to bioavailability, while the less harmful, become more toxic due to bioavailability. Okay, I just see that is the chat box here from Prof. Prof. The nanoparticles are very small in size. Can nanoparticle drug preparation also form residues in tissues? Yes, Prof. Yes, they can. They're very small, because they are loaded into the drug is loaded in the nanoparticles. Yes, they can remain in the tissues for a long time. And what we do is when we study the drug loaded with nanoparticles, we need also to study the residual quantity, the withdrawal period. All has to be determined, before we could approve the drug for use in livestock animals, especially livestock animals. Okay, the next point would be, the properties that influence toxicity. yeah, dissolution. So I just mentioned about dissolution, yeah. So dissolution ability of the nanoparticle is significant, it's very important. So determines the safety, the uptake, yeah, the uptake of the product, yeah, product into the circulatory system. So two identical nanoparticles, yeah, have of similar composition. They have like similar, everything similar, and size, yeah, similar composition and size may have completely different behavior in dissolution. So how they become, they dilute or dissolve in solvent and form a solution can be different. Yeah. So this depending on the surface modification or the surface coating. So nanoparticles, yeah, that undertake media dissolution, yeah, before uptake by organism usually have clear ion channels, and they are preferred by cellular entry route. Okay, usually they enter by the cell entry. Okay, and the last one, I guess, yeah, for the property of the nanoparticles that influence toxicity would be agglomeration. Yeah, agglomeration, yeah, the terminology that I told you just now. Yeah, that's the seventh property. Yeah, it's the seventh, yeah, agglomeration. So here, the nanoparticles are likely, yeah, to agglomerate in solution, yeah, due to the free surface energy. So what they do is they try to avoid agglomeration or clumping. Agglomeration is actually like it's when particles they stick together, yeah, to form groups, yeah, which are loosely attached. Yeah, they can be sometimes can be detached, yeah, but they're in the group form, yeah. And, so the toxicity of nano materials or nanoparticles is also dependent whether agglomeration occurred. Okay, because studies has shown, look at the next slide, studies has shown that agglomeration, yeah, is it induces inflammatory lung conditions, yeah, according to a paper, yeah, cited in 2014. So agglomeration of the nanoparticles could be a potential inducer of inflammatory lung conditions or pneumonia. Okay? So this issue or this problem usually, yeah, more commonly seen, yeah, in carbon nanotubes, yeah, oxide nanoparticles. So the one that the well dispersed carbon nanoparticles have reported having less toxicity as compared to the agglomerated carbon nanoparticles. So the one that freely well dispersed nanoparticle will have less toxicity. And next we'll be on the mechanism of nanoparticle toxicity. Yeah. So there are some papers, yeah, on the mechanism of nanoparticle toxicity. So the general mechanism, yeah, by which the metallic, the metal, okay, as you know, most of the nanoparticles are metal, yeah. So the metallic oxide nanoparticle induces toxicity, yeah. Toxicity is a joint function of the nanoparticles, and its corresponding ability to induce ROS. So if you can see there, yeah, the nanoparticles, you can see the balance, yeah, it's tilted one side, yeah. It's the generation of ROS, yeah, the reactive oxygen species, yeah. So you can see the hydroxyl groups, yeah, the OH, yeah, H2O2, hydrogen peroxide, and all those. Yeah, these are reactive oxygen species. Yeah, which will eventually cause damage to cells. Yeah? It's very cytotoxic. Okay, and yeah, so that is on the mechanism. Yeah? It's on the ROS. Okay, yeah. So redox, it's written there redox potential. So it's positive. It's going to be redox potential positive, which means the measurement of the tendency of the environment to oxidize or reduce substrate. Yeah. So oxidation is happening. Yeah, that's where you get generation of ROS, leading to oxidative stress. So the mechanism, basically there are many, but what I would say here is the prime mechanism would be oxidative stress, and DNA damage, and then inflammation, inflammation mediated nanoparticle toxicity. So inflammation, okay, it is actually it is also related to oxidative stress, because with oxidative stress, all these problems will appear, the pathological problems, the inflammation, necrosis, tissue damage, so okay, they are interrelated. And others would be cytotoxicity, genotoxicity, neurotoxicity. We'll look at that very briefly. The others mechanism of toxicity. So here, in nanoparticle-induced oxidative stress, the pro-oxidants, are the chemicals that induce oxidative stress. So they create either the reactive oxygen species, the ROS, or they inhibit antioxidants. What are the antioxidants? Anyone? Anyone know what do we use as antioxidants? Sometimes we take it in our daily life as a supplement. What would be the major antioxidant? Siapa tahu tak?
Reduce the oxidant.
Hmm?
Reduce the oxidative stress.
To reduce oxidative stress. So, so give me one example of an antioxidant. Is there any supplement that we take daily as antioxidant?
Vitamin C.
Yes, very good. Yeah, excellent. Right, vitamin C. Yes. Yeah, so that's why we are asked to take 500 milligram or even like 1000 milligram. Yeah, for this vitamin C daily. Yeah, it has got many properties. Yeah, it's a very potent antioxidant. Okay, so nanoparticles, they react with the cells. Yeah, they produce, they induce their pro-oxidant effect. Yeah, they induce pro-oxidant via the intracellular ROS generation. So this involves the mitochondria, and also the activation of NADPH dependent enzyme mechanism. Okay. So the more questions. Yes. Yes, this is cool. So the question is I saw, and sorry, I just saw Anthony has replied. He said vitamin C. So when ROS happen, will it lead to oxidative stress? Yes, and damage to tissue when it happen in bigger amount. Yes, I will show you the mechanism later on. Yeah, we will look at that in detail, right? What ROS can do to us. Okay, right. So next would be the roots of the ICA. So nanoparticles, they activate the cellular redox system. So this is especially in lungs, where the immune cells, including like alveolar macrophages, and the neutrophils, they act as the direct ROS inducers. Yeah, so once the redox system, is activated, especially in lungs, so these immune cells, including like neutrophils and macrophages, they act as direct ROS inducers. They cause the generation of ROS. Yeah, so these nanoparticles, they can activate. So that is the adverse effect of these nanoparticles. And so this, when they are activated, they induce production, the generation of ROS via the NADPH oxidase enzyme system. So I'm not going to go in detail on the NADPH oxidase system. I'm sure like one of the lectures, pharmacology has touched on that. Okay. And okay, the next one. Okay, so this figure, right? So this is the figure, that maybe will clarify the question, asked to me just now, on ROS production, and defense mechanism. Defense mechanism is the antioxidant defense mechanism, right? So this diagram, it shows how nanoparticles, they induce oxidative stress. They disrupt the balance, of ROS and the antioxidants defense. So when they disrupt the balance, that's where you get the problem starts when the ROS, when you look at the balance just now, more leaning more towards to ROS. Yeah, if it's like if the antioxidant defense is strong, you can level the balance. Okay, become equal. You won't see the effect. But if it's lopsided, one-sided, then we start to see the effect on DNA and other enzyme inactivation and so on. So here, if you look at the figure, the figure. Can you see my cursor on the figure? So my cursor, I'm moving the cursor. Is it? Can you notice that? No. My mouse tu saya gerak-gerak atas cursor, saya tunjuk. Tak boleh, tak boleh.
Nah, lihat, Prof.
Oh, tak bergerak, Tak boleh. Tak apa. Sebab kadang-kadang kalau saya yang share ni kan, mungkin saya boleh control the mouse. Tak apa. Saya yang explain bit by bit, kita pergi perlahan-lahan, tak apa. So kalau tengok figure ni kan, superoxide, the O2, superoxide, the hydrogen peroxide, hydrogen peroxide, superoxide, dan hydroxyl radicals, the OH radicals. I hope you can see on the diagram, the OH, bahagian yang sebelah kanan kiri saya, OH, nampak. Lepas tu sebelah kiri saya juga ada H2O2, yang tu hydrogen peroxide, dua tu OH. Dengan sebelah kanan saya ada gambar yang O2 negatif tu, superoxide. Click to start the mouse. Okay. Nampak tak mouse saya? Can you see my mouse? I'm moving
Yes.
actually.
Yes, Prof. Yes, Prof. It's
Okay,
clear.
well, Clear? Is
Clear,
nampak?
clear. It's clear enough.
Okay, cantik.
Okay.
Sebab saya risau nanti saya bercakap seorang macam. So this is the hydrogen peroxide, yeah. So this is the central point, yeah. This one you must know the hydrogen peroxide, the OH, and also the superoxide. So these are the main processes, yeah, leading to cellular and molecular damage, yeah, if they are not neutralized effectively. So if there's no balance, yeah, between the generation virus and the defense mechanism, yeah, it will cause cellular damage, right? Okay, so here you can see the nanoparticles, yeah. The first thing, yeah, NP, it interacts, yeah, with oxygen in the environment or the biological system, yeah. Then this can lead to the formation of, we call it a singlet oxygen, okay. Okay, so it will be the generation of singlet oxygen, and then nanoparticles, yeah, also interact with other organic compounds, right? And this arrow showing nanoparticle metal ion reduce, yeah. So nanoparticles, they also reduce metal ions, okay, metal ion, which means like from ferrum 3 plus, yeah, to ferrum 2 plus. Okay, so that means nanoparticle, yeah, it sets the stage, yeah, for the ROS generation. Yeah, the metal ions are reduced. Okay, so this is the arrow, and here, yeah, the next one would be the superoxide production. All right, you can see here my cursor, superoxide production. So the oxygen, yeah, the oxygen is converted to superoxide ion. Okay, ion. Here is converted to superoxide ion. Okay, this may occur by through the cellular metabolic processes or interactions catalyzed by the nanoparticles or the reduced metal ions. Okay, and then the third thing is the conversion, yeah, the conversion of hydrogen peroxide, yeah, hydrogen peroxide. How it happens, yeah, it's actually with the help of SOD, yeah. SOD refers to superoxide dismutase. Yeah, you can always refer, yeah, it's referred to superoxide dismutase. So this SOD, yeah, SOD, it converts, yeah, the superoxide, yeah, superoxide into hydrogen peroxide, right? Hydrogen peroxide, eh? So hydrogen peroxide, yeah, is the detoxification system, or we call it antioxidant defense. So this is the antioxidant defense mechanism, right? Here, yeah, as you can see, the catalase, yeah, CAT refers to catalase. It converts, yeah, the hydrogen peroxide into water and oxygen. Okay, so this is the neutralizing mechanism, yeah. Yeah, it produces hydrogen, oxygen and water, and also the glutathione, yeah, peroxidase, yeah. It detoxifies this hydrogen peroxide into water, and GSSG refers to oxidized glutathione. Okay, it becomes from the glutathione peroxidase. Yeah, it detoxifies the H2O2. Yeah, to reduce glutathione GSH, and then it converts to GSSG, which refers to the oxidized glutathione and water, right? So this one is the defense mechanism. And the thing that on the equation is the Haber-Weiss reaction, and Fenton reaction, these two reactions. Here, the Haber-Weiss reaction, this is the superoxide, superoxide. It reduces, ferrum 3 to ferrum 2, right? So ferrum 3 from ferrum 2, and it also activates the Fenton reaction. And there is the reduction, from this ferrum 3 to ferrum 2, it activates Fenton reaction. Right? And both the cycle, the Haber-Weiss reaction, and also the Fenton reaction will generate OH, or the production of the hydroxyl radicals. So these are the radicals that cause damage, to DNA, the protein, and they cause enzyme inactivation, and then the lipid, peroxidation, and many others, right? So this one, so this in here it shows, this diagram shows how nanoparticles, they induce oxidative stress, by disrupting the balance. Okay, somebody asked about the balance production of the ROS. So it disrupts the balance of ROS generation and the antioxidant defenses. So when it's disrupted, therefore, the damage happens. Okay, so this will lead to cellular and molecular damage if it's not oxidized, or if it's not neutralized effectively. Okay, I hope it's clear. Is it okay?
Yeah, that's very clear, Prof.
Okay.
Thank you.
All right. Okay, next slide, So next slide is just to show you that, the ROS, induction by nanoparticles is considered primary cause of nanotoxicity. And this is attributed to the presence of pro-oxidant, functional groups to the reactive, the surface, or due to the nanoparticle interactions. So toxicity of nanoparticles, attributed to oxidative stress, followed by DNA damage. When there is DNA damage, definitely the mechanism of apoptosis will take over. Right? So DNA damage, so the chromosomal undergoes fragmentation, the DNA strand break, and then they might also induce gene mutations. Okay, next, so this is just to mention that these nanoparticles, they can interact, with the proteins, the serum, the fluid, in the human body, or animal body. So the accumulation of nanoparticles in various organs, and the adverse effects. So the question was like, is there residue? Yes. even though they're very in the small form, yeah, they could also elicit residual problem in the animals. Have hindered the use of these nanoparticles in the field of medicine, and also deterred the potential use in molecular diagnostics and as well in drug delivery systems. But bear in mind, there are a lot of ways, how we overcome the problem of this accumulation of nanoparticles and side effects. A lot of attempts has been carried out and has been researched, to circumvent the toxicity. Right. So next, it's on the inflammation-mediated nanotoxicity. Yeah. So this is it's a different mechanism where the body involves several molecules. Yeah. So this is following infiltration of the phagocytic cells. Yeah. So in normal inflammation, it's like a normal inflammatory process. So there are many studies also, with nanoparticles have shown the induction of inflammation in many cells. Okay. So with inflammation, they cause directly toxicity and clonal cell death through the induction by the toxic byproducts of inflammation. So the byproduct, okay, so inflammation, after the inflammation happens, the products, that are produced, or generated are the ROS, again, reactive oxygen species, and complement proteins, as well as receptor-induced apoptosis and necrosis. And the next toxicity would be cytotoxic effect of nanoparticles. So this is what my student Sherry Fett and have studied the cytotoxicity of nanoparticle that is derived from the cockle shell. Actually, we got the extract of the calcium carbonate. This calcium carbonate table form the shells. So here, again, even the cytotoxicity, is induced by ROS generation. So it's actually the ROS, the first mechanism here. It branches out to many. You can also the inflammation leading to ROS. ROS by itself. Then the cytotoxicity also induced by the production of ROS. And here, perturbation. Perturbation is the alteration, any function, in the biological system. It can be due to internal, or external mechanisms. So, perturbation of calcium, intracellular calcium induced by materials, it's a major cause of cytotoxicity induced by nanoparticles. Okay, and then the next one would be just some notes on the calcium mediated toxicity. So here you can see that it has a direct toxic effect on the mitochondria, and that will respond in the apoptotic pathway. So apoptotic referring to the apoptosis pathway. So next, genotoxicity, nanoparticles. So these are some of the things that we must be aware of. So again, I've mentioned it's not like nanoparticles are not good at all. They can produce whatever being mentioned the slides, but we must take the initiative always, to try to reduce the side effects. So the mechanism here is mainly due to the overproduction of reactive nitrogen species and ROS. Again, it's always referring to ROS. So results in increased oxidative stress and hence oxidative damage to the genetic material. So it's very specific. So this NPS or nanoparticle mediated production for ROS or RNS can be due to the intrinsic production or interaction with the cell target or inflammatory reactions. So I'm going to show you in a short while here. So the next slide says that the damage to the genetic material, it could be direct or indirect. So direct, indirect, primary or secondary. Primary refers to the interaction of the nanoparticles themselves. So that means they have direct contact with the DNA, the genetic material. In secondary genotoxicity, the genetic damage occurs as a result of ROS or RNS produced, carried by the particles. So here it can be direct, directly, which is, that's primary, and could be secondary as a result of the ROS that is produced by the particles. Okay, so this is just to share with you the next one. I think I got our table there, So the table is clear. Okay. Yeah, the writing is small, but it's okay. Right? You can this is just not for you to remember each point. What is the nanoparticle and in vitro studies done and in vivo studies done. This is just to give you an overview, of the genotoxic effect of nanoparticles, based on the studies done, based on the research done in vitro and in vivo. Okay. So mainly they did it on the carbon-based nanoparticles. As we know, most of the in practice, they use carbon-based nanoparticles and also the the metal nanoparticles, the silver nanoparticles. So here research has been done, the carbon-based nanoparticles, and you can see, in vitro and in vivo studies has revealed on the genotoxicity of the nanoparticle. Same goes to silver, silver nanoparticle, gold, titanium, but titanium, has got very long list now as compared to the others, So I think that's why many people, many researchers, many studies is on silver nanoparticle. Right. Okay, so we move on to the question in the chat. Sudah ada catatan dapat. Okay, right. Okay, it's a very good question, Okay, are we more concerned about the toxicity or the benefits? Well, I would say we Okay, it's very similar, very similar to other drugs, that are being using at the moment, in pharmacology. Many drugs, that are very important, to get the function, to the normal phase, So we have to use drugs, and with drugs also we have side effects and toxic effects. But what we do is, in principle, we try to avoid the drugs that that have a long list of toxic effects, because we can choose, because even like within a class of drugs, for example, like antibiotics, compare like penicillin and aminoglycosides. So like penicillins are pretty safe drugs as compared to aminoglycosides. So if there is a choice, for me to choose based on the spectrum of activity, to treat an infection, I would always go for a drug that has got less toxic effect or adverse effect. So similar to nanoparticles, it is available, it is available, but we should be aware of all this toxicity, But given a choice, we have to weigh both the harmful and the benefit, the harmful effects and the benefit to us. But if the benefit outweighs the harmful effect, the side effects, there are side effects, but not as great as the beneficial effect, If the beneficial effect outweighs, that means
Kemarin jenengan turun Artos atau turun terminal, Mas?
Saya Artos.
Artos.
Saya lihat.
Kalau sekiranya macam the beneficial effect adalah lagi banyak, jika dibandingkan daripada dengan side effect, baik kita guna guna produk tersebut dengan mengambil kira side effect tu akan muncul, tapi kita cuba minimizekan ataupun cuba kurangkan dengan intervensi lain. So saya harap yang tu menjawab soalan inilah, Prof. What do you think, Prof? What's your opinion?
Yes, it's very interesting, I think. Karena saya juga masih belum paham betul atau belum menguasai terkait nanopartikel. Tapi ini menarik, Prof ya. Jadi ini suatu pilihan juga ya. Kalau saya melihat kan toksisitas yang ditimbulkan ini cukup menarik ya, membentuk ROS, kemudian DNA damage, kemudian cell damage, itu kan toksisitas yang cukup daya toksik yang kuat sebenarnya kan ya. Jadi itu tadi yang membuat saya bertanya-tanya, apakah memang kita harus betul-betul, artinya memperhatikan betul apabila kita akan membuat suatu formulasi yang menggunakan teknologi nanopartikel ini gitu ya. Oke ya, terima kasih penjelasannya. Artinya memang itu juga harus toksisitas dari nanopartikel ini memang juga harus kita pahami betul. Jadi saya menganggap menarik kesimpulan seperti itu, harus betul-betul tidak hanya dari benefitnya saja ya, memang mungkin tadi yang mempertinggi bioavailability-nya, kemudian lebih murah juga mungkin ya, karena mungkin dosisnya juga lebih sedikit ya.
Betul, drug dosage yang betul. Saya ada
iya, lebih sedikit. Tapi dipahami dan diperhatikan betul. Ya, begitu Prof. Menarik juga sebenarnya.
Terima kasih. Kalau nak buat research tu bolehlah, insyaAllah kita boleh buat.
Iya.
Saya ada juga buat nanopartikel yang on liposome encapsulated drugs. So dalam nanopartikel
ya.
liposome.
Ya,
So
betul, betul.
liposome are less toxic, sebab
Ya.
dia
Jadi ada pelapis atau ada intervensi bahan lain begitu ya, Prof ya?
betul.
Ah,
Kalau ada
oke.
intervensi yang lain yang
Ya,
lebih
ya, terima
bagus.
kasih. Mm-mm.
Right. So the neurotoxicity, it's unreversible. Okay, so this, okay, you can see the table. Yeah, so these are some papers, on the neurotoxic effects of some nanoparticles. Yeah, so this can be reversible, irreversible. So once you stop the treatment, so it becomes reversible. Yeah, so it might affect the function, the neurons in the nervous system. So again, here neurotoxicity is due to oxidative stress, triggered by the free radical activities. So the next slide will show you the table. Saya ada masa lagi ada 10 minit boleh? Dia sikit lagi lah nak habiskan.
Silahkan Prof.
Boleh saya teruskan
Boleh.
So yang table yang seterusnya adalah table neurotoxic effect of nanoparticles. Table nombor 3. Ada ni. Slide seterusnya. Okay. So yang ni banyak research telah dibuat. So ada reference kat situ, memang ada dengan saya. Yang ni nanoparticle macam carbon, natrium, silver, the titanium, iron, silica. So these are the common nanoparticles that they use, and they can see the toxic effects lah. So mainly when I see neurotoxic effect ni, it starts from inflammation, and then ROS formation. Lepas tu bila ada oxidative stress, peningkatan dalam stress oxidatif ni, dia akan merencatkan sel, mitosis sel, lepas tu dia akan mengalami apoptosis dan sebagainya. So dia adalah berkait rapat lah dengan apa yang saya telah bincangkan sebelum ni on inflammation and ROS formation. So, sama juga dengan silver, titanium dan others. So selalunya berkait rapat dengan oxidative stress and decrease of the antioxidant capacity, right? Then the titanium also reduces oxidative stress, inflammation, neurons, and others. They signal disrupt the signaling pathway. Neuroinflammation, then silica, it affects the cognitive function, and so. Right. Okay, we'll move on to the next topic. I think I have on animal exposure. So this slide, it's a very interesting slide. Exposure to nanoparticles. So animals are exposed to nanoparticles via oral, dermal, intra-utero inhalation, lactational routes, So these are the routes. I show you the cursor. So nanoparticles, the exposure, to different routes, and then so this some of the toxic effects to animals, and I think very similar in the. In humans, I think they have more studies as compared to animals. Animals, we are in the stage of developing and testing and trying. I don't see many products in animals. That the drugs are loaded with nanoparticles. But in future, there is a big area to explore on the use of nanoparticles as drug nanocarriers. Okay, so here again similar concept, which I mentioned. They can lead to inflammation, ROS generation, and deposition in different organs. it also been said that this nanoparticle can lead to allergy reaction. Yeah, if it's not compatible to the to individuals. Yeah, and oxidative stress and so on. Okay, and further, leading to DNA damage. Yeah? So here, DNA damage, in detail, they have list out, what are the DNA damage leading to, yeah. So it becomes like the chromosomes, gradually become shorter, it's distorted, with each cell division, telomere shortening, it's actually referring to the ends of chromosome, become shorter with cell division. And then the mitochondrial dysfunction, DNA methylation, and all this. Yeah. And at the same time, you can see the arrow, the protein denaturation also, will lead to oxidative stress. Yeah. Enzyme dysfunction and protein oxidation leading to oxidative stress as well. So all in whole, Fartox is referring to it's a programmed cell death characterized by the accumulation of lipid peroxidation, and it is dependent on the presence of ion. That's why it's referred as Fartox, so referring to iron, presence dependent on iron. Okay, so all this leading to apoptosis and necrosis. Okay, there's a question here. What products should we pay attention to minimize the source of products? What products should we pay attention to minimize? Especially source. So we are worried about this non-toxicity. In animals, even though we don't have to like worry so much, at the moment, because not very much of this intervention has been created for the use in animals. Okay, so I believe that at the moment we are quite safe, to consume the meat, egg, and milk, unless we are using that for therapy, in animals. Then we have to be cautious. Otherwise, I think at the moment, not many products or that I know of that use nanoparticles, as the carrier molecule. Okay. And the next question is, good afternoon, Prof. As nanotechnology becomes more integrated, fully detect specific effects. Yes, I agree with you. Yes, we are looking into nanotechnology, of veterinary products. How long-term and species? Long-term. Well, I think the world is going towards the use of nanoparticles, But as far as I'm concerned, in Malaysia, we don't have many tests. I'm being honest with you that even some of the mycotoxins tests and whatever in feed, we still send to other countries, for confirmation of the presence of the toxin. So there is not a lot of investment in Malaysia on the conventional toxicology assays methods, yeah, to be developed in Malaysia. So especially in the in veterinary medicine, human medicine, I think they are quite advanced, but not in the veterinary medicine. So still until now, even some of like genetic testing, the test kits are not available in Malaysia. Yeah, only some for some diseases, yes, but not all. Until today, we still send samples, outside. Yeah, we source out for labs that can perform the test for toxicology, genetic mutations, yeah, in special breeds of dogs and other animals in Malaysia. So we are not there yet, I would say. Yeah, as we we are trying our best, but a lot of diversion, yeah, towards other problems in veterinary medicine, yeah. They are more focused on AMR rather than the exposure, any problem with nanoparticles. So the emphasis is not really into this nanotech yet in Malaysia. Yeah, we are aware of the need, but so far I would say, we haven't come to the level, that we could compete with other countries in nanotechnology. We're still doing research, especially with veterinary medicine. Yeah. We are quite behind in tech. I hope, how about in Indonesia? I mean, have you all started working on this nanotech for veterinary products? Sri, is there an answer? Okay, Sri, what do you think? Give me your opinion. In Indonesia, what's the situation in Indonesia? Is it similar to Malaysia? Okay. Yeah, actually, this is pretty new to our country. We are in the same boat. Yeah. So Southeast Asia, yeah, we are on the same boat as Indonesia. Thailand are slightly advanced, I believe. Okay, right. I will just continue with the lecture, yeah. And lastly, yeah, talk about what are the strategies. So this is something which is important, yeah. So what are the strategies? Next slide, yeah. To circumvent nanotoxicity. Okay, so we know that many studies, yeah, in vivo and vitro has recognized, yeah, the role of the main problem is due to the oxidative stress, yeah, that leading to nanotoxicity. So therefore, how to overcome this problem? Yeah. So one way is to prevent oxidative stress mediated nanotoxicity is to give antioxidants, yeah, to balance up the what they call the curve. Okay, so interaction of ascorbic acid and compounds from plant-based compounds, yeah, that contain a lot of phenols, yeah, phenolic compounds, yeah, such as quercetin, yeah. So quercetin is a product, yeah. It's a flavonoid, yeah. It's a flavonoid that obtained from plants, yeah, and shows very strong, yeah, antioxidant effect of potency. Yeah? So these are the things that we could give or could use, yeah, to circumvent the toxicity exposure. Okay. The next slide, yeah, is just to show you that, the things, yeah, to prevent oxidative stress would be the antioxidant induction, yeah, using ascorbic acid, quercetin, yeah, I mentioned quercetin. So quercetin is a flavonoid, okay, it's a flavonoid obtained in plant, yeah, from plants, and also surface modification of the nanoparticles, yeah, so that it's less harmful and less toxic, yeah, to the environment, to human, to others. Okay, I think the others I have explained in my lecture before this year on inflammation, oxidative stress, and so on. Okay, the next slide would be, yeah, ascorbic acid, use of ascorbic acid, yeah. So here, like introducing ascorbic acid into the AG nanoparticle treated acute myeloid, yeah, leukemia cells, yeah. So there is a complete decrease in the ROS production. So this is something that we need to consider. Yeah? That we know that it could lead to, a harmful effect, but by introducing the antioxidants, yeah, we could see some progress of the patient. So ascorbic acid also will lead to the decrease of the AGP and nanoparticle induced mitochondrial damage, yeah, and all the toxic effect will be reduced. Right. Okay, go to the next slide. Quercetin, yeah. So this is especially for plants, yeah. Many plants and food, yeah. So it's a very potent, yeah. It's reported in many papers, yeah, that I've read of. It has got the antioxidant activity. So it has the free radical scavenging ability. So being a potent antioxidant compound. Okay, and then so how it acts, yeah? So this is going to be another mechanism, yeah, quercetin. So will be another lecture, yeah, if you want to know how quercetin reduces the ferrum oxide nanoparticles induced oxidative injury and inflammation is by through the back phosphorylation. Yeah? So there's a totally another mechanism involved, and NRF2 translocation through the P13K AKT dependent pathway. So this is a very complicated mechanism, yeah, which I'm not going to go through today. Yeah, we will just know about the pathway that it acts. Yeah. So the other intervention that could be done is surface modification of nanoparticles. So this is to decrease the toxic effect. Yeah. So and what they've done, yeah, based on the research that I've read, encapsulation of this ascorbic acid, yeah, with the nanoparticle, yeah, the silver nanoparticles, and found to be effective, yeah, in reducing the toxicity of the silver nanoparticles. So these are the things that could be considered, yeah, to reduce the toxic effect. All right. So some of the applications, yeah, I also mentioned here, yeah. The next slide, applications of nanoparticles. So the nano application is vastly used, yeah, in the in many areas, yeah, in therapeutics, yeah, diagnostic, and others. So they also can be used for delivery of drugs, yeah, such as antibiotics. We also actually in our lab we tested oxytetracycline, yeah, which is encapsulated oxytetracycline with the calcium carbonate that is derived from cockle shell, yeah, and to prevent disease in goats, yeah, a very specific disease, yeah. Sure, I don't know whether you have done this disease ruminants, yeah, was towards against this caseous lymphadenitis, yeah. So it was a very good study, I would say, yeah. So we did see some effect when it's in the encapsulated form, yeah. It prevents a lot of factors, yeah, the drug from getting destroyed, because as you know, like caseous lymphadenitis, you know, there's formation of granuloma. So it was like a drug alone, you know, it was unable to penetrate, yeah, the granuloma. But with the when the drug is embedded, yeah, or encapsulated with the nanoparticle calcium carbonate particle, yeah, the penetration was better, yeah, as compared to the drug is given. So that was another study that has been done in my lab. Okay. So the next slide is there are more applications. Yeah. So they also use in feed, another thing. Yeah. Besides we're talking about drug, so on. But in veterinary medicine, yeah, the encapsulation of feed components. So this is to protect, you know, the feed from oxidation, breakdown by light, and so on, you know, to keep away from lysis, yeah, the enzyme like proteases and so on. So they encapsulate the feed, yeah, so that it will last long. Okay, this is one of the uses, yeah, of this nanoparticles, yeah. So just found that the pH has improved, yeah, and then good mixing of additives. When you put like a feed additive, other probiotics or probiotics, yeah, into the feed, yeah, as a feed additive. They found it like it helps in the mixture, good mixture of the compound of or the product like in the feed, okay, which will prolong the action. So this was a big problem, you know, in animal production, especially, yeah, the problem of mycotoxicosis. And they detected this in the feed. So by using this technology, yeah, using the nanosilica or the nano magnesium oxide, they find it like it was very, very useful. Yeah. So this is actually based on a study, based on research. Yeah. So it's considered a very powerful nano anti-mycotoxin, yeah, which that bind successfully to these aflatoxins and inactivate them, yeah, and to improve the pH of the feed and reducing the incidence of mycotoxicosis. So this is something that to think about, right? And yeah, the next slide would be also in hormones, yeah, sustaining the release of hormones. That means it's being released slowly, yeah, into the circulation, yeah, for absorption. So they play a very important role, yeah, nanoparticles in vaccine production, yeah, because they improve these are the good things, yeah. improve the immune response. Okay. So they serve as adjuvant. Sometimes we have adjuvant, and with adjuvant, vaccine that which adjuvant base, sometimes we find it very difficult to inject to animals, right? But with this technology, it makes the antigen slowly release and easy to administer, the vaccine, which will also in future, that it will increase the performance of the vaccine. So the animals will get less disease with this technology. Okay, I think I came. Yeah, that's the that sum up the lecture for today. And lastly, I think I have one conclusion slide. So just to remind everyone that nanoparticles, it's a great potential in medicine, due to their favorable physical-chemical properties. But at the same time, the toxicity is a growing concern. So we have to weigh the balance. There must be a balance of both. Okay, and numerous in vitro studies, demonstrated the main toxic effect of this nanoparticles that induce ROS, causing the imbalance in the redox state and leading to oxidative stress, and so okay, all this after all this consideration of the toxic effects, so that will open up a new era, or a new page for the synthesis of more safe, efficacious, and more effective and less toxic nanoparticles. All right. That's all I have got to say today. Is there any questions?
Okay. Thank you very much, Dr. Arifah, for your insight and great delivered presentation. Now is a section and question session. Please, to all participants, feel free to raise your question directly or submit your question via chat box. Anthony.
Okay,
Please, Anthony.
Can I ask the question? Okay. I noticed that one of the main causes of what's hindering the use and development of nanomedicine is its effect of induced oxidative stress. Now, there is an effort of neutralizing that effect with the encapsulation of vitamin C with silver nanoparticles, I believe, in the slide. My question is, does it neutralize the toxicity trait completely, or does it only reduce the toxicity slightly?
Then remove the toxic effect completely. That's reduction on the toxic effects seen in the patient. So that was according to a paper. You can also look on this in the websites. There are many papers published, how they try to reduce the effect. Usually, it's kind of like very difficult, to completely abolish, the effects, completely to remove the toxic effects. But the interventions done here is like to reduce, the effect of the nanoparticles.
Okay, I see. Thank you, Professor.
Yes, you're welcome, Anthony.
And others, maybe? Yang lainnya? Bisa kah? Okay, Ayu, please. Open your mic, Ayu. You still mute.
Okay, thank you so much for the chance. I wanted to ask, since nanoparticles has either beneficial and have toxic effects on animals or and environment, I wanted to ask that, is there any adequate regulations to control the use and disposal of nanoparticles to prevent contamination to environment or to prevent the toxicity in animals? That's it. Thank you, Professor.
The toxic effect the environment. So far, in Malaysia, well, it's actually underreported, I would say, since yes, I agree that it could be in the environment and not detected, maybe in the water polluted with this nanoparticles, in the river and so on, and we use that, the source of water for the animals, in the farm and so on. But currently, I think the emphasis on this detection of this nanoparticles, these nanomaterials, in water and other environmental, what do you call, other environmental places, the menu, so not really being highlighted in Malaysia. So we haven't really gone into seriously, in detecting nanoparticles in the environment yet. Say that. Did I answer your question? Is that your question?
Ayu? It is
Yes.
Okay, thank you very much, Ayu. Maybe one question, okay, more? Ada pertanyaan lagi? Untuk satu pertanyaan, silahkan. Okay, Professor, I have one question. Are ROS or and RNS always the main markers of nanoparticle exposure, or there are other specific biomarkers that are starting to be used?
Okay, I didn't get you.
ROS.
Ah.
Yeah. ROS, maybe the other specific biomarker.
Specific?
Apakah ROS selalu menjadi penanda utama dalam paparan nanopartikel, ataukah ada biomarker spesifik lain yang bisa digunakan? Biomarker.
Saya tak berapa pasti lah biomarker yang spesifik yang digunakan untuk toxicity particles, sebab mungkin ada kot, ada, because when we do the for antioxidant property testing and so on, so there are a lot of assays that we can see the activity of the antioxidant activity So is it whether it's reduced or it's normal, or is it enhanced? So there are many essays on that to determine the antioxidant activity. Yeah. So at the same time, we could speculate the ROS activity. All right, based on the essays that we have. Yeah. Uh, uh, that I mentioned just now, the catalase, the glutathione superoxide assay, and there are many assays for antioxidants lah, which can be used, as an indirect tool, to determine the ROS activity.
Okay, thank you very much, Professor. Maybe that's all. Thank you very much, Professor. Because the time is almost
So
over.
sorry, yeah. It's supposed to be 2 until 4. I'm so sorry. It's taken your 20 minutes of your time. Yeah. I hope
because
that was
time is
useful.
almost over. Once again, we sincerely thanks for Professor Dr. Arifah Abdul Qadir for sharing her available insight, and all participants for actively engaging in today's session. We hope this section will inspire new research direction and collaborative opportunities, especially advancing safe and effective nano-based veterinary medicine. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Saya kembalikan kepada Salma sebagai Master of Ceremony. Have a pleasant day.
Terima kasih kepada Ibu Ida Triana S. Apteker MSc PhD yang telah memandu jalannya sesi kuliah dengan sangat menarik sehingga dapat meningkatkan semangat dan antusias kita untuk mengikuti diskusi tadi. Dan tentunya terima kasih kepada Associate Professor Dr. Arifah binti Abdul Qadir yang sangat luar biasa. Semoga ilmu yang diberikan beliau tadi dapat menambah wawasan dan pengetahuan kita semua. Sebagai bentuk apresiasi atas ilmu dan pengetahuan berharga yang telah disampaikan pada hari ini, kami ingin menyampaikan rasa terima kasih kepada pembicara yang terhormat Associate Professor Dr. Arifah binti Abdul Qadir, dan kami mengundang Profesor Arifah untuk menerima sertifikat apresiasi sebagai simbol terima kasih dan penghargaan dari kami. Dilanjutkan dengan sesi dokumentasi. Kepada panitia yang bertugas, kami persilakan untuk dokumentasi penyerahan sertifikat.
Dua, tiga.
Sudah?
Ya.
Baik, sudah didokumentasikan. Sekali lagi kami ucapkan terima kasih kepada Profesor Arifah atas waktu dan ilmu yang telah dibagikan kepada seluruh hadirin pada siang hari ini. Terima kasih banyak, Prof. Arifah.
Thank you so much, Prof. Arifah.
Stina, and thank you all who participated in today's lecture. It was a very nice and welcoming ambience, and I really enjoyed the lecture with you students, and you students are very good, very participative, and a lot of questions came out from you students and others. Thank you very much, and please do keep in touch. And that's all from me. Have a nice day.
Thank you, Prof. Thank you. Have a nice day.
Assalamualaikum.
Waalaikumsalam.
Sekali lagi kami reminder ya untuk teman-teman mahasiswa untuk presensi yang ada di kolom chat, jangan lupa diisi gitu, karena presensi mungkin akan segera ditutup ya. Dan untuk hadirin yang berbahagia, tanpa terasa saat ini kita sudah di penghujung acara. Pada kesempatan ini, kepada seluruh partisipan yang telah mengikuti kuliah tamu pada siang hari ini, kami berharap sesi kuliah tamu pada hari ini dapat bermanfaat bagi kita semua. Saya selaku Master of Ceremony mohon maaf apabila terdapat kesalahan dan kekurangan selama memandu jalannya acara pada hari ini. Demikian sesi kuliah tamu bersama Departemen Farmakologi Fakultas Kedokteran Hewan Universitas Gadjah Mada. Saya Salma pamit undur diri. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you so much,
Okay.
Thank you so much,
Prof.
Arifan. See you next time.
Inshallah, see you in the UGM.